Hello everyone, myself Krishna Kovate. I am from MIT Academy of Engineering. Today I am going to present implementation of FIR filter using DSP processors with the help of my group mate Haram Barambe and our guides Nathan Baisal. Here are some outlines for our presentations. Firstly, we are discussing about problem statements and their objectives. Then we are going to discuss about the introductions and we are going to discuss some basics information about FIR filters and their different types and our implementation and the results, and then we are discuss about some formulas and calculations, then conclusions, and there are lastly some references. Our problem statement is that to implement an FIR filter using TMS320F28335 DSP processors, our objectives are to design and implement a filter using dedicated DSP processors, and our next objective is that to analyze the noisy signal, and third one objective to calculate desired frequency response coefficients. Fourth objective is to calculate windows coefficients to, and fifth objective is to calculate output signal, and last objective is to analyze output signals. And there are some introductions. In nature, natures there are no totally clean signals. In that, if we go anywhere, there are signals totally distortions. Uh, Before they may be utilized for applications, these distortions may be eliminated by using filters. Here we are going to use FIR filters for these distortions. The filters are allow us to specific band of frequency to pass through them and attenuate all other frequencies. There are different types of filters categorized on the basis of their band frequencies. Low pass filters and high pass filters both are filtered using their cutoff frequencies. There are many input signals can be filtered by one digital filter without replacing the hardware. Digital filters have characteristics like linear phase, which is not possible to obtain in case of analog filters. In this implementation, we are going to use TMS320F28335 DSP processor, which is based on velocity architecture. These are very high performance, advanced very large instructions and word architecture. This processor consists of multiple execution units running in parallel, performing multiple instructions during a single clocks. Here are some basic introductions about filters. In that, in our education, there are two filters. Firstly, IR filters and FIR filters. In that, uh, in that we are going to take brief discussion about FIR filters. FIR filters stands for finite impulse response. These filters are digital filters that have infinite finite impulse response. Filters operates only on current and past input values, and are the simplest filter to design. These filters are also known as recursive filters. Example of these filters is our cell phones. These FIR filters are provides a linear phase response, where the IR filters provides non-linear phase response. FIR filters are best purpose because they implemented using an all zero transfer functions. FIR filters are used for applications that require linear phase response, like high quality audio or low quality audio systems. There are different types of windows. There are firstly we are discussing about rectangular windows. Rectangular windows has magnitude of 1 for the range n equals to 0 to m minus 1, where m is the length of the filters. Here is a formula for rectangular windows. Omega r equals to 1 for if n is equals to 1 to m minus 1. Otherwise, this will 0. Second one is most popular window, that is Henning window. The Henning window was inventor was von Hahn, and his gives a Henning name due to his shape. His shape is like one cycle of a cosine wave with added one, which is always positive. The formulas for Henning windows is omega of n, which equals to zero point 0.5 into 1 minus cos of 2 pi omega pi n divided by n minus 1 for n is less than 0 to m minus 1. There is a next window, that is Hamming window. The name was given by R.W. Hamming. It was recommended for smoothing the truncated autocovariance functions in the time domain. Its function given as in mm. Next, fourth one window is that Blackman window. In Blackman windows, we find one more additional term in comparison with Hamming and Hanning. Because of addition of cosine term, side lobes are reduced further. Window functions for Blackman can be given as a WPF equals to 0.42 minus 0.5 cos 2 pi n minus 1 plus 0.08 cos 2 4 pi n minus 1. Uh, Here we are done with some basics about filters and introductions about our topics. Now we are here to show our implementation results. We have did implementation using the MATLAB GUI. Here, firstly, we are discussing about rectangular windows implementations using air filters. A rectangular window is also known as Dirichlet window or box car. It is the simplest window and equivalent to replacing all but n values of data sequence by zeros, making it appear as though the waveform suddenly turns on or off. The time domain of frequency domain of rectangular window, in which the relative side lobe attenuation is minus 13 dB and main lobe width is 3 dB, which is nothing but 0.17188. The next window is Hamming window. This was proposed by uh, scientist Richard Hamming. The windows is optimized to minimize the maximum side lobe, giving it a height of about 1/5. That is that of the Hamming windows. The time domain and frequency domain of Hamming window, in which relative side lobe attenuation is 35.8 decibels and main lobe width is minus 3 decibels, which is nothing but 0.2734. Next window is Hamming window, which was whose inventor was Owen Hahn. He gives the name due to his shape. The shape of this windows is 1 plus a cosine of wave, which is an always positive number. The sampled signal values are multiplied by the Hamming functions and results is shown in figure. Note that ends of the records are positive and zero regardless of input range. The highest level of side lobes are about 32 dB down from the main lobe. Uh, there are some formulas most helpful softwares uh, for for implementations. Efficient hardware implementation of filter using signal process is done by using the GUI. From this result, we conclude that final output signal has the only one fundamental frequencies. All other frequencies have been heavily attenuated through the filters algorithm. It is also observed that DSP reduces tedious calculations and computers convolution was quickly and save a lot of time. The digital signal processor has a wide range of uses, and one of them is creating filtrations, which is helpful for amplification and also in the sounds. The DSP can filter real-time signals using ADC and DAC, and the output the processor results on an oscilloscope, which is connected through our DSP processors. There are some reference which we have taken help from that for implementing the FIR filters using. Thank you.